All right, welcome to part 2 of this video because technology is wonderful sometimes. So we're on that fourth bullet that starts with atoms that do not have a valence shell that is full. Okay, everybody good where we're at? Atoms that do not have a valence shell that is full of electrons are reactive, meaning that they want to combine with other atoms. Highlight reactive and meaning that they want to combine with other atoms. They want to fill that outermost shell. Start with reactive. Reactive, meaning that they want to combine with other atoms. So they can either give away electrons, they can steal electrons from another atom, or they can work out an agreement and share electrons with another atom. And depending on what they do to balance that outer shell will determine what type of chemical bond it is. Atoms bond when the valence electrons of one atom interact with the valence electrons of another atom. Last bullet there, a molecule forms when two or more atoms bond together chemically. Highlight that statement. A molecule forms when two or more atoms bond together chemically. And it gives an example of water. Then down there at the bottom, we start with Lewis dot structures. Lewis dot diagrams are a way to show what those valence electrons are in the outer layer and what they are doing. And you are going to be creating some Lewis dot diagrams. Okay? If you look on the next page where it says step 1, step 2, and step 3, it walks you through that process and gives you an example. So notice with chlorine, you have two atoms on three sides of the chlorine. I'm sorry, not atoms, electrons. I misspoke. Two electrons on each side of the chlorine, except for one. Now, how many atoms fit in that outer layer? Who can tell us? What's the maximum amount of electrons? I keep saying atoms. I'm sorry, my coffee's not kicked in. It's 8. You can fit 8 electrons in that outermost layer. How many does it have? 7. So how many does it need? 1. It needs 1. Okay? So it either needs to steal 1 electron from another atom, or it needs to kick out 7 electrons and give them away to other atoms. You do not want me to call your name out as I'm recording a lesson because you're not doing what you're supposed to be doing, and the entire 8th grade will know it. Next slide, please. All right, we're on the right-hand side, ionic bonds. So there are different types of bonds based on what the electrons do to fill those outer layers in the atoms. So ionic bonds are the result of an attraction between two ions that have opposite charges. Okay, so this is if an atom has a positive charge and another one has a negative charge, opposites attract. Okay, that is a true scientific principle. Opposites attract. So that positive and that negative attract to each other. Letter A. Remember that atoms are electrically neutral in the perfect world, right? Because they have the same number of protons and electrons. The positive and negative charges cancel each other out. When two atoms come close enough that one of the atoms steals an electron from another atom, 2 ions are created. Okay, so look at letter B. Highlight. And I can never say these words correctly, so I say this cation. It's not cation. It looks like it would be said cation, but it's not. It's like cation or cation. I don't know. Different people say it different ways. I say it cation because I like cats. So the cation, if an atom loses 1 or more electrons, it becomes a positive ion. Highlight that statement. Cation. If an atom loses one or more electrons, it becomes a positive ion. What charge does electrons have? Negative. Electrons have a negative charge. So if you lose electrons, you're losing negative charge, which means that atom is now positively charged, right? It is understood that that is the case. As somebody who has been married almost 30 years, you definitely don't want to live with somebody who's exactly the same as you. So it's good that you have some opposite characteristics, but if you are like complete polar opposites, that could be difficult too. So, all right, letter C. Anion. Highlight anion. If an atom gains one or more electrons, it becomes a negative ion. Highlight that. If an atom gains one or more electrons, it becomes a negative ion. Next slide. About halfway down under those YouTube links, highlights. It's going to be tricky getting the correct box. Click down below, like the bottom, and it will put the box around the correct letters there. Ionic bonds usually occur between metals and nonmetals. Highlight that. Ionic bonds usually occur between metals and nonmetals. That III is a typo for me. I did not separate those things out. It's part of the outline. So when I copied this from the student notes to put in your presentation, I didn't format it correctly. And then it gives you an example there. Now we're at covalent bonds. See where those words covalent bonds are? Highlight that in bold. Put those in bold. So you see that that's a different section, please. Yes. So just make that bold print. Highlight it and make it bold. You click the big capital B at the top to make it bold if you don't know how to do that. All right. Down below the little YouTube link there, covalent bonds, not bombs. We're not talking about making bombs here. We're talking about making bonds, just to be clear. Covalent bonds form when electrons are shared between atoms. Highlight shared between atoms. In ionic bonds, atoms give away or steal electrons. In covalent bonds, atoms share electrons. You have to know that difference. In ionic bonds, they're kicking them out, they're throwing the electrons out, or they're stealing them from someone else. In covalent bonds, they're nice. They share, okay? Covalent bonds often occur between nonmetals. Highlight that. Covalent bonds often occur between nonmetals. And then an example of a covalent bond is carbon dioxide. Again, pay close attention to those examples in your notes. They will be used in your test questions. Right-hand side. Again, highlight metallic bonds and put that in bold, please. Metallic bonds. So what do you think these bonds have to do with? Metals, yes. Metallic bonds only exist in metals. Highlight that. Metallic bonds exist only in metals.
Wait, do we have atoms in our body?
Yes.
We do?
Yes. Metallic bonds exist only in metals. And then number 2, electrons are free to move through the metal atoms. Highlight this. If you stick a metal fork in the light socket, what's going to happen? Yeah, it's not going to be good, right? Because metal is a good conductor of electricity, and this is why. Because the way metals bond to other metals, it makes it to where the electrons can move freely among the atoms. Yes, like if you put a fork in the toaster, please do not do that. So the important thing to know about this is electricity is essentially just those electrons moving from atom to atom. That's what electricity is. Okay? That's different. All right. Hydrogen bonds. Highlight hydrogen bonds and make it bold. Who did hydrogen for their project? Okay. Hydrogen is very unique because it only has one proton and one neutron, and oftentimes does not have an electron with it. It just lets other people or other atoms have its electron. So that's okay, because the perfect world it does. Hydrogen bonds are unique because it just has that one electron. So letter I, which should be Roman numeral 1, a force of attraction between a hydrogen atom in one molecule and a small atom of high negativity in another molecule.
Which one's smaller than the other? I would forgot.
Electrons are smaller. Roman numeral number 2, when hydrogen atoms have their electrons unequally shared with the other attached atom, the partial positive charge on the hydrogen is highly concentrated because of its small size. Highlight that. When hydrogen atoms have their electron unequally shared with the other attached atom, the partial positive charge on the hydrogen is highly concentrated because of its small size. So the other atom will carry a negative charge. Positive charges are attracted to negative charges, but no actual physical connection occurs between adjacent molecules. Highlight, no actual physical connection occurs. So in the other bonds we've talked about, there is a connection because of the sharing of electrons or the giving away of electrons or the stealing of electrons, or in metallic bonds, those electrons are just bouncing back and forth between atoms. In this case, it is more like a magnet. There's not a physical connection, but they are really attracted to each other, so they're really close together, okay? Number 3 down there, hydrogen bonding also have a very important effect on the properties of water, proteins, and nucleic acids. That's just an FYI. Next slide. Letter C. What elements want to react? Elements want to find another element that will complement their outer valence electrons to give the atom a full outer shell. Highlight that. Elements want to find another element that will complement their outer valence electrons to give the atom a full outer shell. We have already said that once and highlighted it once. If we're highlighting it twice, you darn well better know it. Down to compounds. Letter A, highlight. When atoms of elements are joined together, a compound is formed. It's under compounds. Letter A. When atoms of elements are joined together, a compound is formed. That's what you highlight. Letter B. Chemical formulas. A chemical formula of a compound shows the relative number. Start with shows. Highlight, shows the relative number of atoms of each of the elements in the compound. Allie Bell, will you go ask Mr. Johnson if we can have about 3 more minutes, please? Right-hand side. Letter B, empirical formula. And letter C, molecular formula. Those are different types of formulas that we will look at. There's nothing to highlight there. Slide 10. Thank you. Letter D, structural formula is another type of a formula we'll look at. If you look on the right-hand side, we're on slide 10. Right-hand side, chemical bonding and nomenclature. After that word nomenclature, click after that and type naming system. Nomenclature is naming system. That's what that word means. Okay, so now we're talking about how things are named based on the types of bonds the molecules have. And again, there's nothing really to highlight there. Those are things we're going to go over, but nothing that I expect you to memorize and remember forever and ever. Slide 11. This continues with the types of bonds and the nomenclature. So it tells you, like in covalent, tells you how the number of covalent bonds there are. So it will be a mono or a di or a tri or a tetra. Hopefully you learned those words like in elementary school when you were talking about shapes and stuff. And that is it. That is the end of your notes. So keep in mind, you need to review these notes each evening. You need to review your Quizlet set each evening. Okay, so you're talking about 15 to 20 minutes each day that you need to go over this. If you're really smart and you learn science really easy, you can alternate and do notes one night and Quizlet the next and back and forth. Okay, you will not always be able to use your notes on the test.